1811, May 6, 2025, right now marks 1048 hours of progress on the global horror simulation and a major breakthrough, as after dozens of hours, the custom 3D model view projection matrix system without any external libraries is finally working. What's really good about this is it allows for the creation of a 3D camera and objects to be positioned correctly in front of that camera without the use of external libraries. So all the 3D math code was written completely from scratch. Well, some tutorials were looked at, though just copying and pasting code blindly without actually understanding how it all works does not lead to a good result. One of the major problems early on was not knowing about a world matrix, so an object was just positioned in front of the camera, but it didn't have a world matrix, so when rotating it, it didn't look accurate, and beyond that, there are certain nuances to creating a 3D model view projection system, such as knowing the difference between the left-right-handed and right-handed coordinates, as well as a very interesting bug that can occur if one does not convert certain data to radians. And the reason that the data needs to be converted to radians is that when creating such a system from scratch, one is likely to use CMath functions, and some of those functions, if one is passing in something that represents degrees or just random variables, those variables need to be converted to from float to radians, or just their natural or they need to be converted to radians, and if they're not, then weird results can occur, such as this, which is demonstrating what happens when the FOV accepts a value that has not been converted to radians before processing it within the function that creates a left-handed perspective projection matrix. And what occurs is that, seen here, the object starts moving in the opposite direction it should. In a left-handed 3D renderer, the y-axis should point upwards for positive, and the positive x should be on the right. And what was really difficult to track about this bug is that it actually isn't a problem with the view matrix or the projection matrix or the world matrix, which this has been a bug that has taken several hours to sort of track down. And so those matrices were constantly being rewritten completely from scratch, but after rewriting the entire thing from scratch for a second time, the bug still appeared. So just looking through it, what was noticed upon rewriting it the second time was that a custom projection function was made, rather than using the one from the Bardcode engine, which is a tutorial about DirectX 11 that actually showed how to create a custom matrix system. But the problem with that tutorial is that they supplied a class for a custom matrix for X4 type, but the other such stuff, such as how to actually build the world matrix and projection matrix and view and such as that stuff, was not really, there weren't set functions for that. It was sort of just a bunch of variables cobbled together, which didn't show one how to build that own system from scratch using that. Now, as demonstrated here, it works accurately. Or is this the actual, so passing that in without that and changing the FOV, weird things happen where it appears to sort of flip around the entire, it sort of inverses it in a way. It's probably something much more different from inversing, but yeah, it just sort of starts going in opposite directions than what it should be doing. But converting that to radians solves the problem. 75, which is sort of a normal field of view, when converted to radians is around 1.57. So as one can imagine, sending in 75 directly is like a huge value. And there's actually two functions for that, convert to radian and convert to radians, which are custom functions that have been created for this. And the reason to create a 3D camera system from scratch is that one might want to implement 3D physics in the render, and the tutorials for that sort of implement their own math libraries, and in order to easily follow along, one should probably know about matrices and it just makes it easier to sort of overload types, because custom 3D physics tutorials overload types and they add new operators and such and functions, and if one is using a library such as DirectX Math and one does not know a lot about 3D physics to begin with, or 3D math, then it really poses a challenge in sort of following those 3D physics tutorials, which are sort of necessary in order to build a 3D physics system from scratch with the within a custom code base. And yeah, so the intention going forward, now that this camera system is, this left-handed perspective projection camera is finally working correctly along with the world view matrix and the other matrices, the intention is to just add other features such as looking into physics and animation and such. But this is actually really good. And another thing to figure out is what is a quaternion, because that seems to be something that is fundamental for learning 3D physics completely from scratch. Yeah, so the scene here, the field of view is working perfectly. So as it's increased, it looks wider, and as it's decreased, things sort of come closer. Although they're not really closer, the position of the object isn't changing, but the field of the view is what's changing. Yeah, so this is finally working correctly. A very tedious bug to track down, which is only actually tracked down by creating a custom perspective field of view function for a 4x by 4x matrix type, which is all a camera really is a view and a projection, and perhaps some actual functions to set the eye and target and to look at. So that's actually here. So there's an eye, there's a target, there's an up, and it's actually really nice to see it just finally come together.